yesterday, I guess you were absent yesterday. बाकी सबको मिल गई है. So in order to access the recording, you must have to log in through the same Gmail ID जो आपने मुझे दी हुई है, right? जो आपने मुझे Gmail दिया हुआ है, आपने उसी से ही उसको ज्वाइन करना है, उसी Google अकाउंट से. I mean उस डिवाइस में वही Google अकाउंट log in होना चाहिए. So Bismillahirrahmanirrahim. Today we will be doing applications of reversible reaction. Yesterday we started with this very important chapter called reversible reaction. Now let's quickly review the entire thing in reversible reaction, starting with the definition, the condition to achieve, the dynamic equilibrium, then the conditions to achieve dynamic equilibrium, and what are the characteristic features. I want everyone to recall the same concept which I'm referring to. So first of all, you all should be able to explain what is meant by reversible reaction. A chemical reaction that goes in both forward and backward reaction is called a reversible reaction, right? So when the rate of the forward and backward is equal, we can say that the reaction has achieved dynamic equilibrium. Now, under what condition the system can achieve equilibrium? There is only one condition. The condition is the system has to be a closed system. The examiner may ask why there is a need to have a closed system. So why there is a need to have closed system, starting with Noor? Yes, Noor. Why the system has
the gases formed may not escape.
Yes, excellent. So if the gases form, or the gases on the reactant side, if they escape, there won't be any forward or reverse reaction. So if there is no reverse reaction, there is no equilibrium. Once the equilibrium has established, I hope I'm audible. सबको आवाज आ रही है मेरी?
Yes, sir.
Yes.
Excellent. Okay. So once the system is at equilibrium, there are two features. Number one, as you can see on the screen right now, the rate of the forward and the backward are equal at equilibrium. And number two, at equilibrium, you can see the concentration of the reactant and product, it does not changes, or you can say the concentration of both sides stays the same. These are the two conditions. Now, we have few factors that can affect the position of equilibrium, like we have factor those who can affect the rate of reaction. For rate of reaction, there are 5 factors: the temperature, the pressure, concentration, catalyst, and size of particle. Here, for the equilibrium, we have 3 factors that can affect the position of equilibrium. One is temperature. I told you yesterday, whenever you are going to predict the change to the position of equilibrium, when you change the temperature, the first thing that you will check would be the enthalpy of that reaction. That if the enthalpy, either the enthalpy is positive or negative. If the enthalpy is positive and you are increasing the temperature, equilibrium goes to the right side. Why it moved to the right side? To absorb the excess heat, forward reaction is favored, as the forward is endothermic, more product are made. And if the enthalpy is positive, you decrease the temperature, equilibrium goes to the left side, as the forward is endothermic. To compensate the effect of low temperature, backward reaction is favored. This is exact opposite. For a reaction whose enthalpy is negative, that means forward is exo, backward is endo. So whenever you increase the temperature, endothermic reaction is direction is favored. So here, when you increase the temperature, equilibrium goes to the left side because backward is endothermic. And when you decrease the temperature, forward is favored because forward releases heat, and system will again try to achieve the same equilibrium. The second factor that may affect the position of equilibrium is pressure. And the good thing about pressure is it only applies to the gases, right? So we only need to consider the mole of gases on both sides. If there is solid, liquid, or gases, you have to ignore the way you ignore your chemistry teacher for the last 2 years, I believe, in your school, right? So for pressure, we have again 2 factors. So either you can increase the pressure or you can decrease the pressure. Let's first look at the effect of increase in pressure. So when you increase the pressure, equilibrium goes to the side with lesser moles of gas, as Zainab mentioned yesterday, like diffusion, high to low. So Look at this very example. We have calcium carbonate, reverse reaction with calcium oxide and carbon dioxide. So on the left, we have 0 moles of gas. You see, we have 0 moles of gas because there is only one reactant and it is already solid. So you ignore the solids, liquids, aqueous things, and other than gases, जो भी है सबको ignore करना है आप. On the product side, we have only 1 mole of gas. So we have 1 here, 0 here. Whenever you increase the pressure, equilibrium move to the side with lesser moles of gas. तो इसमें increase पे जाएगा left, decrease में उस तरफ जाता है जहाँ पे ज्यादा moles होते हैं. So to compensate the effect of low pressure or high pressure, make no difference. Okay. So we have nitrogen and hydrogen. Together they react to form ammonia. In this very example, we have 4 moles of gases on the reactant side. We have 2 moles on the product side. As you increase the pressure, it goes to the right. You decrease the pressure, it goes to the left, right? And we know that a catalyst, it has nothing to do with the position of equilibrium. It cannot alter. Catalyst cannot change the position, the equilibrium. It just cannot. But what it can do is it can help the reaction to achieve the equilibrium quicker. I mean, if initially the reaction is taking more time, in the presence of equilibrium, I mean catalyst, since catalyst increases the rate of both forward and backward, it just, catalyst increases, speeds up both forward and backward. ऐसा नहीं है कि सिर्फ फॉरवर्ड को ही स्पीड अप करेगा. It speed up the reaction, I mean going in the forward direction or it's going into the backward direction. So, but it cannot alter the yield. It cannot alter the equilibrium, which means it cannot change the yield. ये किसी चीज की amount को change नहीं कर सकता. Yes, अगर amount change होती है तो it is affected by the change in temperature, change in pressure, change in concentration. The last factor is the concentration. So the idea of concentration is the side, equilibrium में देखो reaction में 2 sides हैं. जिस side में concentration low होगी, equilibrium will move to that side. So if you remove the product, the concentration of this side will decreases, equilibrium move to the right side until you get the same amount of product. If you keep on removing the ammonia, there won't be any reverse reaction. You will only have forward reaction. If you keep ammonia bani aapne nikali, ammonia bani aapne phir nikali. So if you keep on removing the ammonia, the concentration of the product will remain low and the equilibrium will remain on the right side. There won't be any backward reaction as long as you are removing the ammonia. Or if you are keeping the concentration of the reactant high, you are adding more and more reactant. अगर reactant add कर रहे हो, concentration of reactant बढ़ रही है, तो equilibrium will remain again on the right side. Make sense, everyone? To compensate the effect of high or low concentration, whatever, you can add both. So, any question from the equilibrium, conditions, features, or factors? Excellent. Today, we need to look into the applications of dynamic equilibrium, and let me tell you, these are important. And not just important, but definitely would be part of your paper. Doesn't matter if it is MCQ, theory, or sometime ये उसमें भी आए हुए हैं. I mean practical. So applications of dynamic equilibrium. I mean अगर देखो forward और backward same है, तो फिर हम ये reaction कर क्यों रहे हैं भाई? Why there is a need to carry out this reaction if they are happening at the same rate? Nothing is changing. Forward is backward are equal. Then what is the exact purpose of achieving this dynamic equilibrium? So the application of equilibrium is, or the reversible reaction is more accurate. Number 1 is formation making of what do we call Haber process. That's the number 1 application. And Haber process, we make ammonia production. Right? I hope you all know the formula of ammonia. Ammonia is represented by NH3. It is a simple molecular substance with low melting and boiling point. Why it is simple molecular? Anyone in the class, mic is open. Ammonia is a simple molecular substance. The question is, why it is simple molecular? Shabash.
It has a
Yes,
smaller number
Sharia.
of atoms.
Yes, Abdullah. कौन बता रहे?
Nile.
Yes, Nile.
It has a small number of atoms.
Okay, ठीक है.
Sir,
Anyone else?
has
Nile
sir,
says it has small
covalent-
number of atoms. Mhm.
sir, covalent bonds contain two types of nonmetals, different nonmetals. So the
Okay.
nitrogen and hydrogen are both nonmetals, and that
Hmm.
is this is a covalent bond. And covalent bond के दो
Hmm.
types होते हैं, simple molecular और giant covalent होते हैं. तो इसलिए ये simple
Okay.
molecular है. इसका
Okay. Yes, yes, Ayla.
Sir, I was gonna say that it's like made of one element. That's why.
It's not one element, Ayla. If you look at the formula, we have nitrogen and hydrogen. They are two different elements. Okay. So any substance which contain two non-metals, it is always simple molecular except three: the diamond, the graphite, and the silica. So nitrogen is non-metal, so does hydrogen. And as I mentioned, it is gas. Every gas has a simple molecular structure, weak intermolecular forces. That's why it is a gas, right? Sharia, please switch off your camera and your mic. Okay. So every gas is simple molecular. I mean, gas है इस वजह से क्योंकि वो simple molecular है. And it has weak intermolecular forces. Weak intermolecular forces. So less energy is required to break the intermolecular forces. Now, the more important thing is the uses. I mean, we are making ammonia. Before we make ammonia, we must focus on why there is a need to make ammonia. Iska use kya hai bhai? So there are two important uses part of our syllabus. Can you tell me those uses? Anyone in the class? What are the specific uses?
sir, is it
Shabash.
used to make fertilizers?
Excellent. One is it is used to make fertilizers. It is used to make fertilizer, not fertilizer. I mean, to make fertilizer. Yes, anyone else? What is the other use? अमोनिया कहाँ पे यूज होती है और all right.
Sir, I'm not sure, but I'm not sure if I remember this correctly. But gold packs.
Not really. I'm not sure about that. हो सकता है यूज हो रही हो. Okay. चले अब इसके देखते हैं कि how can we make ammonia? First, to make ammonia, we need some elements called raw material. तो ammonia को बनाने के लिए the raw material is nitrogen. एंड सोचें आप सब लोग इसका सेकंड यूज एंड द हाइड्रोजन. वैसे एक ही हमारे सिलेबस में है, सल्फ्यूरिक एसिड के दो हैं. हाइड्रोजन. अच्छा, नाइट्रोजन and hydrogen are the sources of, I mean, the raw material of to make ammonia. So raw material कहाँ से आएगा? What is the source of nitrogen and the source of hydrogen? Nitrogen का source is, there are two sources of nitrogen. One is nitrogen का एक ही source है. The only source of nitrogen is fractional distillation of air. Air से आती है और किस टेक्निक के थ्रू? Fractional distillation of air, because I told you few days back, air में कितने % नाइट्रोजन है?
78%.
78%. So you can extract nitrogen from the air, and the technique is called fractional distillation. अगर आप सिंपल सोर्स पूछ रहे हैं तो आप air भी लिख सकते हो. Air contain 78% of nitrogen. Sources of hydrogen, there are two different sources of hydrogen. One is you can have hydrogen from the electrolysis of water. Electrolysis of water भी कह सकते हैं या aqueous salts भी कह सकते हैं. So electrolysis of water से भी आएगा. And the other is cracking of hydrocarbons. Cracking of अभी हम चैप्टर पढ़ेंगे organic chemistry इंशाल्लाह. So both cracking and electrolysis, cracking of water, electrolysis of hydrocarbon, they produce hydrogen as one of the product. So you can have hydrogen from cracking or electrolysis and nitrogen from air. You can make them react under certain conditions. This is the symbol equation. Okay, so nitrogen can react with hydrogen. We know it's a reversible reaction. You can get ammonia. Now, every element, I mean, reactant and product here, they are gases. at room temperature. Nitrogen is gas, so does hydrogen. Ammonia is a gas, we know. Let's balance this. हमने बहुत टाइम लिखी हुई है, यहाँ पे 3 लिखेंगे. क्यों 3 लिखेंगे पहले इसकी बात का? We have 2 nitrogens, तो यहाँ पे 2 लिखेंगे. Nitrogens are balanced. Up we have 6 hydrogens, तो यहाँ पे 3 लिखेंगे. We have 6 hydrogens. Makes sense, everyone? So under what are the conditions when? So the ratio is, if you look at this equation, one molecule. When I say one molecule, that means 1 mole of nitrogen exactly reacts with 3 moles of hydrogen to make 2 moles of ammonia. That is the molar ratio here. 1 mole of nitrogen exactly reacts with 3 moles of hydrogen to make 2 moles of ammonia. That's the molar ratio. It's a reversible reaction, and the condition to make ammonia, we need 450-degree temperature. That's the condition. We need 200 atm. That's the amount of pressure required. And there is a catalyst that we use. It's called iron 3 oxide, or simply iron is also acceptable. So let me write the conditions on this side. What are the conditions? This is the raw material. These are the uses, and the conditions. एक use, I think मेरे mind से भी slip हो गया, but anyhow अभी आ जाएगा. Conditions में number 1 condition है, I mean, as I mentioned, temperature. The other one is pressure and the catalyst. So temperature is 450 degrees, pressure is 200 atm, and catalyst is iron 3 oxide. It's not simple iron oxide, iron 3 oxide. So the formula is Fe2O3, right? So the function of the catalyst cannot alter the position. It is just to help the speed up the reaction both forward and backward by increasing. I mean, in the presence of catalyst, you can have equilibrium more quickly as compared to in the absence of catalyst. So that's the overall symbol equation. Now, where does the equilibrium involve? I mean, how can you maximize the product? Let me write the equation again. Nitrogen, hydrogen, and ammonia. System is at equilibrium. It's a closed system. As long as the system is closed, forward and backward are equal. So the question is, under what conditions? Okay, one thing that I forgot to mention, the enthalpy of this reaction is negative. So you must know that forward releases heat. If enthalpy is negative, that means the forward reaction is releasing heat. If forward is releasing heat, then the backward reaction is absorbing the heat. So the question is, under what conditions the yield of ammonia is increased, can be increased? So what are those important conditions? By changing those conditions, you can increase the yield of ammonia. That's the question. When I say you can increase the yield of ammonia, that means how can you forcefully, by changing any of these conditions, equilibrium पे था तो forward और backward same rate पे हो रहे थे. जैसे ammonia बन रही थी वैसे ammonia it is going in the backward direction. But how can you adjust your reaction by changing certain conditions so that the equilibrium disturb ho jaye and it only goes in the forward direction to make more ammonia? Now we all know that. Let's look at the pressure first. We have 1 gas here, 3 gases here, and this is also gas. Imagine the pressure at which the equilibrium is established. Pressure is 200. The pressure is 200. Question, everyone, what would happen to the position of equilibrium if you increase the pressure? 20 seconds. What would happen to the position of equilibrium when you increase the pressure from 2 to 300 atm? Shabash. Yes, Amna.
It will move to the right side.
It will move to the right side. Amna, would you please explain that why it goes to the right side? Amna says, when you increase the pressure, equilibrium move to the right, and when it will move to the right, you will definitely get more ammonia. That's correct. But Amna, what is your explanation to your answer, to your statement?
To balance the equation, इसलिए वहाँ पे pressure ज़्यादा हो गया, तो वहाँ पे moles
आपने बताना है, ये आपने ये बताना है moles. Whenever it is about pressure, Amna and everyone, you have to refer to the number of moles of the gases on both sides. So as we know that on the left side, how many moles are there? We have 1 mole of nitrogen, क्योंकि इसके साथ कुछ नहीं लिखा हुआ, and we have 3 of hydrogen. तो total कितने moles हैं हमारे पास gases के? 4. On the right side, we have only 2. So when you increase the pressure, equilibrium move to that side where we have less moles of gas. तो जब मैं pressure increase करूंगा, तो less right side पे, you will get more ammonia. तो what is the first condition? High pressure. तो जैसे जैसे आप pressure high करोगे, you will get more and more ammonia. But आपको एक बात मैं बताता हूँ, you cannot increase, आप pressure increase करते ही नहीं है. You maintain the pressure 200 atm. So why we cannot increase the pressure? Anyone in the class? Pressure हम increase करेंगे, तो you will get more ammonia, but we do not increase the pressure. Why? Shabash. Any wrong or right answers? I mean, every answer is right. Yes, Alia. Ayla.
Sir, I'm not sure this is right, but is it impossible to add more pressure?
No, it's possible. Perfectly possible. You can increase the pressure. There is absolutely no problem. Look, this is already a very high pressure, 200 atm. So increasing more pressure would cost a lot of, बहुत ज़्यादा expensive equipment आपको buy करना पड़ेगा. So you can increase pressure, but that increase will increase the yield. That is true. But वो increase कम होगा, लेकिन आपका expense ज़्यादा आएगा. क्योंकि increasing, maintaining the high pressure is very costly. बहुत ज़्यादा पैसे लगेंगे. तो हम लिखेंगे, but it is very costly. It is very costly or not cost effective. Because to maintain such high pressure, imagine इस रूम में, या आप जिस रूम में बैठे हुए हैं, वहां पे कितना प्रेशर है? 1 atm. इस रूम में 1 atm प्रेशर है. So 2 atm double. तो ये 200 atm, already he is at 200 atm. So increasing the pressure would give more ammonia, but that is not cost effective. So 200 is an optimum pressure where you get a healthy amount of ammonia at a good rate. Now imagine the forward reaction is exothermic. The forward is exothermic, and the system achieves equilibrium at 450. Forward is exo, और 450 पे इसका equilibrium है. What would happen to the position of equilibrium when you increase the temperature? Yes, Shameen, आपसे पूछ लेते. What would happen to the position of equilibrium when you increase the temperature?
Sir, I had a
Come.
question.
Yes, please.
Sir, increasing the temperature of ammonia, sir, usse can it cause damage to the environment? Like if you increase
Increasing the temperature or pressure?
Sorry, pressure and temperature.
No, we just stick to one. I mean, we initially discussed the pressure. When you increase the pressure, ammonia is a gas, nitrogen is gas, hydrogen is gas. Since we have lesser moles of gas on the right side, you will get more ammonia. Nothing to do with the environment. You simply will get more ammonia. But that ammonia, वो जो बनेगी वो कम बनेगी, जिस तरह मैंने कहा, उसके ऊपर जो एक्सपेंस आएगा, जो खर्चा आएगा, जो पैसे लगेंगे, वो ज्यादा होंगे. Because to maintain high pressure involves such modern equipments, modern आपको devices चाहिए, which are very expensive. That's the first disadvantage of increasing high pressure. The second question is, what would happen? I mean, the forward reaction is exo. What would happen to the equilibrium when I increase the temperature from 450 to 550? Yes, Anaya, आपसे पूछ लेते हैं.
Sir, if we increase the temperature, the reaction would move backwards because
Excellent.
it
Why?
will go towards endothermic because it will have to absorb the excess heat that's being produced,
Excellent.
and then
Excellent.
therefore
I mean,
more
perfect.
reacting will be created.
Yes. So basically, when you increase the temperature here, since the forward reaction is exothermic, as you increase the temperature, the equilibrium goes to the backward. इसका मतलब ये है कि when you decrease the temperature, तो हमें temperature क्या करना चाहिए? Temperature decrease करना चाहिए. A low temperature will shift the equilibrium to the right. Whenever the enthalpy is negative and you decrease the temperature, equilibrium goes to the right. You increase, it goes to the left. But we already have 450, तो हम अगर 450 से कम करेंगे, you would definitely get more ammonia. लेकिन हम 450 से कम करेंगे नहीं. So why we do not decrease the temperature from 450 to like 200 or 100 or 50? जैसे जैसे temperature decrease करेंगे, you will get more and more ammonia because equilibrium उतना ही right side पे जाएगा. लेकिन हम डिक्रीज करते नहीं, हम 450 पे रखते हैं, क्यों नहीं करते डिक्रीज? शाबाश। Hassan?
Is it because the mass might change its state?
Sorry, I didn't get it. Please, dobara.
Is it possible that I can change its state of matter?
No, it can't. I mean, yes, वो तो बहुत ही आप कह लें कि if you decrease it to negative or उसमें चले जाएं, otherwise it cannot. There is something else. Look, you all know that whenever you decrease the temperature, yes, Zoya.
Sir, does it denature the
Not
catalyst?
at all. We don't have any enzyme here, Zoya.
Okay,
It's an
sorry.
iron, which is an inorganic. Dr. Zoya, it's not a biological enzyme. We have simple iron, which is an inorganic catalyst. Okay, so lowering the temperature, you all know, whenever you lower the temperature, rate of reaction decreases. तो जब आप टेम्परेचर कम करोगे यू विल डेफिनेटली गेट मोर अमोनिया, लेकिन उसमें रेट इतना स्लो हो जाएगा कि अमोनिया बहुत स्लो रेट पे बनेगी. सो 450 इज अ ऑप्टिमम टेम्परेचर एंड 200 इज अ ऑप्टिमम प्रेशर एट विच यू गेट अ डिसेंट अमाउंट ऑफ अमोनिया. तो मैं क्या लिख देता हूँ, लो टेम्परेचर बट इट डिक्रीजेस द रेट. दैट इज अ डिसएडवांटेज. ये मैंने डिसएडवांटेजेस लिखे हैं रेड में. इट डिक्रीजेस द रेट ऑफ रिएक्शन. मेक सेंस एवरीवन? So how can you
Yes,
increase? The question is how to increase the production of ammonia or the yield of ammonia. Now we have discussed 3 factors, everyone. You all know that we've discussed 3 factors and there was a third factor in the factors, and that factor is called concentration. And I think मैंने ये example discuss की थी. Imagine the system is a closed system, and what we are doing here, we just जो अमोनिया बनी है हमने उस अमोनिया को यहाँ से रिमूव किया. So जैसे जैसे आप अमोनिया निकालते रहोगे, so the question is how to increase the production, the yield of ammonia. Number 1, keep removing ammonia from reaction mixer. So देखो जैसे जैसे आप अमोनिया रिमूव करोगे, the moment you will increase, you remove ammonia, आप निकालोगे, the concentration of this side would decreases and you will get more ammonia. वो बनी आपने वो भी निकाली, you'll get more ammonia. The first thing that you can do to increase the production, instead के वो बनी और वापस चली जाए, instead के वो वापस जाए, आप उससे पहले उसको निकाल लो. जैसे आप निकालोगे वापस जाएगी नहीं, फिर और बनेगी until you are getting more and more. Number 1, you keep removing or keep withdrawing ammonia from the mixer. Number 2, you keep increasing the concentration of the reactant. आप reactant add करते रहो. आप reactant add करोगे, the concentration of reactant will remain high. It stays on the right side. So keep the concentration of reactant high. Keep the concentration. ये मैंने आपको reactants high. So जैसे जैसे आप concentration of reactant high रखोगे और अमोनिया को remove करते रहोगे, तो the equilibrium will remain on the right side because right की concentration decrease हो जाएगी by default. So you will get more and more ammonia. So this is everything, students, related to Haber process, जो कि आपको आ सकती है starting from what is the raw material, what are actual use fertilizer है, it's a simple molecular gas and it's a basic gas. ये भी आपको पता होना चाहिए. It's the only alkaline gas. हमारे सिलेबस में इसका टेस्ट क्या है, किसी को याद है अमोनिया का टेस्ट? It's an alkaline gas which turns, क्या करेगी? Damp red litmus को क्या करेगी? ये blue कर देगी. That is the test of this gas. It is an alkaline gas. In the presence of this gas, damp red litmus paper turns blue. If the litmus paper turns blue, that means the gas is ammonia gas. It is produced by the nitrogen and hydrogen. The source of nitrogen is air because it is present in 78%. Hydrogen is electrolysis of water or the cracking of hydrocarbons. This is the symbol equation, and the conditions are 450 degrees, 200 atm, and iron 3 oxide as catalyst. So that's it. And as far as the conditions and everything is concerned, but what are the suitable conditions, the optimum conditions, and why those conditions are optimum? We can increase the pressure to get more ammonia, but maintaining high pressure is costly. So 450, 200 is optimum pressure. We can lower the temperature to get more ammonia, but lowering the temperature would decrease the rate of reaction. So how to increase the yield then? You can change the concentration. You can keep on removing the products and keep on adding the reactants so that the equilibrium will remain on the right side, keep on getting more and more ammonia. Any question from Haber process? Anyone? No question. Ready for
No
contact
question,
process,
sir.
everyone? Excellent. I assume सबको समझ आ गई. Ready for Haber process? Contact process. Contact process. Yes, Zoya, Zainab, Nile, Hassan, and everyone. Excellent.
Yes.
Okay. So, contact process is the second application. And in contact process, what do we make? The king of chemicals called sulfuric acid, right? Now, sulfuric acid is used as an acid in car batteries, and also, since sulfuric acid एक और भी use है यार, it's a solvent भी होता है, but there's another use, so slip हो गया. Second use सबका slip हो ही जा रहा है, anyhow भी याद आ जाएगा. So contact process में what do we make? We make ammonia, sulfuric acid. What is the raw material? Raw material to make sulfuric acid is, there's a list of raw material. We need sulfur. Sulfur solid होता है powder form में. We need, of course, air भी होती है इसमें. That is part of raw material. Oxygen चाहिए होती है. We need water as a raw material. And surprisingly, we need already prepared sulfuric acid भी चाहिए. Sulfuric acid बनाने के लिए भी sulfuric acid चाहिए. Okay. So, what are the conditions? So, ये बड़ा common question है कि सर पहले कहाँ से आई थी? पहले एक और method है जिससे आई थी. हमारे syllabus में contact process है. So, what are the conditions to make? When I say conditions, it should be temperature. So the temperature needed here is exact the same. The pressure is very low here, about 1 to 2 atm, and a different catalyst called vanadium pentaoxide, vanadium 5 oxide. We know what type of element can be used as catalyst? Anyone in the class? What type of elements can be used as catalyst? Transition elements. So both iron and vanadium are transition elements. That's why they are used as catalyst. Okay. Now the important thing here is the list of reaction. Unlike in Haber process where we have only one reaction and directly you can make ammonia. Look at this. You simply react nitrogen with hydrogen to get ammonia. But in contact, it's not that simple. It's a chain reaction. We need to learn that chain reaction. It is very easy. I want everyone to practice with me. So, ready everyone? So, it's a 4-step mechanism basically. I want everyone to write with me. In the first reaction, sulfur, it is burned in excess supply of oxygen to get you sulfur dioxide. Sulfur is solid, oxygen is gas, and sulfur dye is also a gas. What type of reaction is this? It's a reversible or irreversible? What type of reaction is this? Is it reversible or irreversible? इतना आसान है यार, ये तो बता दो.
Irreversible.
It's irreversible. You're burning. So it's a simple combustion reaction. Now, in the second step, I want everyone to write these symbol equation with me. In the first step, you burn the sulfur. In oxygen, burning हमेशा होती है oxygen में, you get sulfur dye. In the second step, sulfur dye is again burned in further oxygen. And this beautiful reaction is चलो मैं अपना favorite color use कर रहा हूँ. This is the only reaction in 4 reactions that is reversible. In the second step, sulfur dye, which is a gas, is burned in oxygen, a gas, to make you sulfur tri, which is also a gas. And in that very step, you use all those conditions which we were referring to. We use 450, 280 m, and we use V2O5 as catalyst in this very step. Make sense, everyone? So in the first step, you burn the sulfur, you get sulfur dye, in the which is irreversible. In the second step, same sulfur dye is further burned in oxygen in a reversible reaction to get you sulfur tri. In the third step, that sulfur tri made is treated with already prepared sulfuric acid, which is one of the raw material. Now, in that third step, you just need to add both of these react. इनको add कर दो. I mean, एक ही चीज बनेगी. देखो, how many total hydrogens? कितने hydrogens बने? कितने sulfur बने? कितने add करके लिख दो बस. शाबाश. करो add, क्या बना? Yes, Nile. What should be the formula of the product if you just need to add everything?
Sir, H2S2O7.
Excellent. Excellent. If you look at the reactant, we have only 2 hydrogens, we have 2 sulfurs, and we have 7 oxygens. And that is the product. This very product is called oleum. You must know the, देखो आपको formula याद रखने की जरूरत ही नहीं. Just add these 2 numbers to reactants and you will get the products. Make sense, everyone? It's very easy, I believe. So ये gas है, ये aqueous है. इसको aqueous लिख दो, liquid लिख दो, एक ही बात. Yes, Zoya.
Sir, will the 2 and 2 not cancel?
Which 2s?
The H2 and S2.
No, it's not like that. इसमें ये है कि देखो बेसिकली आपने अच्छा क्वेश्चन पूछा है. ये वाला असल में देखो ना, हाइड्रोजन इज ऑलवेज +1. सो ये जो पूरा फॉर्मूला है ना, ये S2O7, इट्स अ कम्प्लेक्स एनाइन. इसका चार्ज होता है बेटे -2. देखो, बट दैट इज नॉट पार्ट ऑफ द सिलेबस. तो आपने अगर पूछा तो बता दिए, ये वो वाला 2 नहीं है जो आप इज्यूम कर रहे हो. अगर आप इन दोनों को अलग इज्यूम करो तो इसका क्या फॉर्मूला बनेगा जोया? इसका यही नहीं बनेगा जो ऊपर लिख दिया मैंने.
Yes.
So in the last step, that oleum H2S2O7 is added to water to get you H2SO4. I want everyone to balance this equation. Done? Yes, no? Shameen? Abdullah bhai? Yes, Abdullah. So what should I write on the reactant or product side to balance this equation? Abdullah. How many hydrogens we have on the left side? कितने hydrogens हैं? मैंने label कर दिए. How many hydrogens? 4. यहाँ पे कितने?
2.
तो देखो balance हो गए hydrogens. Done? Yes.
G.
How many sulfurs we have on this side? 2. देखो यहाँ पे पहले से 2 हो गए. यहाँ पे 2 है और यहाँ पे 1 था, तो इसके साथ 2 लिखा तो सबके साथ मल्टीप्लाई होगा ये 2. तो सल्फर पहले से 2 है. How many oxygens do we have on the left side? कितने oxygens हैं?
8.
8. यहाँ पे देखो पहले से 8 हो चुके हैं. Make sense, everyone? Say yes. Excellent.
Yes.
I want everyone to give yourself 1 minute and just revise everything in contact process, especially the symbol equation. I mean the entire contact process in 1 minute, starting with the formula, the use. इसको उसमें भी यूज करते हैं ना यार, फायरवर्क्स में भी. फायरवर्क्स में अमोनिया को यूज करते हैं. आई डोंट नो, मैं स्लिप कर गया. ओके, सो रॉ मटेरियल आपको पता होना चाहिए, कंडीशंस एंड सिंबल इक्वेशन, एवरीवन इन जस्ट 1 मिनट. शाबाश. एंड आई होप आप सबने नोट भी किया है. which reaction is reversible and in which step we use all the conditions, right? And other symbol equations. All right. So in today's class, we tried to complete the topic called reversible reaction. And I'm glad that we learned everything in detail, starting with the Haber process, where we, learn the core concept, core idea that how to make ammonia, why to make ammonia, what exactly ammonia is, how to test ammonia, why it is gas, because it is simple molecular, weak intermolecular forces, less energy is required, used to make fertilizer. I think ये fireworks में भी use होता है ammonia because इसमें nitrogen होता है. And raw material इसका क्या है? What are the sources of those raw material? What is the symbol equation? The conditions, important conditions. तो conditions तो similar ही है ना. यहाँ पे 450, वहाँ पे भी 450, यहाँ पे 200, वहाँ पे simple 2 ATM. Only thing is catalyst. Here we have iron. एक याद रख लो, बच्चे confuse हो जाते हैं. Here we have iron catalyst, और वहाँ पे vanadium pentaoxide or vanadium 5 oxides, and these are important, information about this. Contact में we make sulfuric acid. Raw material is sulfur, air, water, and sulfuric acid. And we see we have 452 ATM vanadium oxide. It is used to make acid as a solvent. Be used in different reactions. Okay, and symbol equation is sulfur burn to give sulfur dye further burn to produce sulfur tri. It's a reversible reaction. And in the third step, sulfur tri is mixed with sulfuric acid to get you an intermediate, which is called oleum. Oleum is added in water to get you sulfuric acid, 2 moles of sulfuric acid. So here I should put 2. Make sense, everyone? Say yes.
Yes, sir.
So you will get, inshallah, every one of you will get a detailed worksheet on these 2 chapters. We are only left with redox, which will start from Monday. And we'll complete redox, inshallah, in 1 lesson. So next pura week, which is Wednesday, Tuesday, and Thursday, Tuesday, Wednesday, and Thursday, we will do topical worksheet from this very chapter. But you will complete the given task. Inshallah, मैं अभी या कल आपको task share कर दूंगा in your respective groups. See you. Allah Hafiz.
Allah
Allah Hafiz.
Allah.
Allah Hafiz. Allah